Hello students, in this lecture we are going to solve a second problem on block diagram reduction. So let's start. Question is to find the transfer function C of S by R of S for given block diagram. So block diagram given to us is this one. So again here we are having R of S as the input to this block diagram or to this system, and C of S is the output, and we are having number of blocks connected in their logical sequence. So let's reduce this block by using the rules that we have studied earlier to get the transfer function. So first step is to look for block in series, block in parallel or minor feedback loop. Now if you carefully observe this block diagram, so here G4 and H1 is forming a minor feedback loop. So this one we can reduce by using the rule of removing minor feedback loop, and apart from that we are not having any block in series or any block in parallel here. What we can do, we can first reduce this minor feedback loop. So let's draw the reduced block here. So we are having summing point and this input R of S to it, then we are having next summing point, then we are having block G1, then we are having block G2, and then we are having this minor feedback loop which we can reduce, and before that we are having a summing point here. So since this summing point is shared by this minor feedback loop and also with G3 and G2, so this summing point will remain as it is, and then we are having a reduced block, that is the closed loop transfer function of this minor feedback loop. So it will be G4 by 1, and now we need to see the sign of this feedback, so it is minus, so here it will be plus G4 into H1. So this is the reduced block, and we will be having next output in the form of C of S. Then in between G1 and G2 we are having a takeoff point which is connecting block number G3 with this summing point here, and it is having a positive signal. Now we will be drawing other blocks that are remaining here. So here we are having block H2 which is emerging after block G2, and it is having a negative feedback signal. Similarly, we are having another feedback signal here, and we are not having any block to it. So this is called as a unity feedback. So here block is having value 1, that's why it is not shown here, and this is also a negative signal. Now after this again we have to search for whether we are having any block in series, block in parallel or minor feedback loop. Now if we observe this diagram, we are not having that. So what we need to do, we need to apply other rules to create block in series or parallel or minor feedback loop. So what we can do here, we can shift this takeoff point here, that is connected to G3. So this takeoff point we can send behind this G1 block, or we can send this takeoff point after this G2 block, or similarly we can send this takeoff point which is connected to H2 behind this G2 block. So here we are having various options, and we have to decide so that our next stage will not become complicated. So what we'll do, we'll shift this takeoff point which is connected to H2 behind this block G2. Now what is going to happen when we are shifting takeoff point after a block, so that block will be connected in series with the feedback signal. So here we will be having G2 connected with H2. So let's draw it. So we are having a input signal R of S to first summing point, then we are having second summing point, and after that we are having block G1, then we have a takeoff point for G3 is coming to the summing point, and again since we have shifted this takeoff point, so it will be also emerging, we can consider that it is emerging at the same point. And next we are having G2 here, and after that we are having this entire block G4 by 1 plus G4 into H1, and then we are having output as C of S, and here we are having block H2, and one more block we have to connect here in series since we have shifted this takeoff point behind this G2, so it will be G2 here. That block we have to attach in series with this feedback signal, and then suppose it is a negative signal, and then we are left with this negative unity feedback signal. Okay, so this one is positive here. So here if we see H2 and G2 are in series, so they can be replaced by a single block, and it will be having transfer function as H2 into G2. And similarly, this G3 and G2 are in parallel because signal is flowing in the forward direction and it is converging to a common summing point. So G3 and G2 are in parallel. So now we can reduce these blocks simultaneously. So let's draw. So here we are having input signal as R of S. Then we are having first summing point, and after that we are having second summing point, and we are having next is block G1. Now to this second summing point we are having a feedback signal, that is H2 and G2. Now since H2 and G2 block are in series, so we can replace it by single block, and it will be having multiplication of these two block transfer functions. So it will be H2 into G2, and it will be connected in this way here. Then we are having G3 and G2 as parallel block, so we can replace it by single block, which will be having transfer function as algebraic addition of these two blocks. So it will be G2 plus G3, and then after that we will be repeating this block as it is. So it will be G4 upon 1 plus G4 into H1, and then we are having output as C of S. Now to this first summing point we are having a feedback signal, and that is a unity. So now if we see this reduced block diagram, what we are having, this G2 plus G3 and this block is in series, and this G1 and this block H2 into G2 is in minor feedback loop. What we can do simultaneously, we can reduce these blocks. So let's move ahead. So again we are having R of S input, and now we are having this minor feedback loop, so we can replace it by its closed loop transfer function, and that will be G1 by 1, and now we have to see the sign. So sign was for both the feedback it is negative, so right now we are considering this minus feedback loop, and since its feedback is a negative, we will be having positive here in the denominator 1 plus, and it will be G1 into G2 into H2. What we did, we have multiplied G1 with H2 into G2 here in the denominator. Next, what we'll do, we are having two blocks in series, so what we'll do, we'll replace it by single block, and this block will be having transfer function which will be multiplication of these two blocks. So it will be G2 plus G3 into G4 upon 1 plus G4 into H1. Then we are having an output as C of S. And here we are having a unity feedback. Now after this, we can see here these two blocks are again in series, so we can replace it by single block. So again let's draw here the reduced block diagram. R of S is input, and now we are having a single block which will be having transfer function equivalent to multiplication of these two blocks. So it will be G1 into G4 bracket G2 plus G3 in the numerator, and in denominator we'll be having 1 plus G1 into G2 H2, and then we are having second bracket as 1 plus G4 into H1. Then we are having E of S, and here with this summing command we will be having a unity feedback loop. So again it is forming a minor feedback loop here. So what we can do, we can replace it by its closed loop transfer function. So again we'll be having a equivalent block here which will be having closed loop transfer function of it. So now first we are going to write this block as it is. So it will be G1 into G4 in bracket G2 plus G3 on denominators bracket, so 1 plus G1 into G2 H2 into 1 plus G4 into H1, and upon, again this signal is a negative, here also it is negative, so in denominator we will be having 1 plus, and again we will be repeating this value into 1 because here we are having feedback as unity. So it will be G1 into G4 bracket G2 plus G3 upon 1 plus G1 into G2 H2 bracket 1 plus G4 H1, and this will multiply with 1 because here we are having a unity feedback, and then we are having P of S here, and of course this one is R of S. Now as we have reduced it to simple form, we can write its transfer function. So it will be transfer function is equal to output, that is C of S, upon input, that is R of S. And also we can simplify this one. So here what we can do, we can in numerator it will be as it is, so it is G1 into G4 bracket G2 plus G3 upon, it will be these two bracket 1 plus G1 into G2 H2 bracket 1 plus G4 into H1 upon. Now here what we can do, we can cross multiply so that we can make a common base, and later on we can cancel with this denominator here. It will be, if we cross multiply, it will be 1 plus G1 into G2 H2 bracket 1 plus G4 H1, and then we are having this term here after plus sign, so it will be plus G1 into G4 into bracket G2 plus G3, and upon, now we are having a common base here, so it will be 1 plus G1 into G2 H2 and 1 plus G4 into H1. So now what we can do, we can cancel this denominator and here this denominator, so we will be left with this numerator and this bottom term here. So it will be G1 into G4 in bracket G2 plus G3, and in the denominator we are having this value, so it will be 1 plus G1 into G2 H2 bracket 1 plus G4 H1 plus this term here, so it will be G1 into G4 bracket G2 plus G3. So this term G1 into G4 in bracket G2 plus G3 is after this positive sign. So this is what is the transfer function for this block diagram. So with this we'll end here.